Okay, let's dive right into this. Have you ever stood on a railway platform, felt the sheer rumble of a massive locomotive pulling in, and just wondered, how on earth does raw electrical power actually translate into the momentum needed to move 10,000 tons of steel? Well, today in this explainer, we're doing exactly that. We're deconstructing the machine. We'll be looking at a fascinating blueprint for a 3D educational animation that breaks down the precise mechanics of a modern train. It's kind of the perfect, highly visual roadmap for understanding some seriously heavy engineering, and honestly, I absolutely cannot wait to walk you through it. So here's our roadmap for today's mechanical breakdown. First, setting the scene. Second, generating the energy. Third, transferring power to wheels. And finally, motion and braking systems. Section 1. Setting the scene. Visualizing mechanics. Now, the overarching goal of our source material is pretty ambitious. This blueprint isn't just about showing a bunch of mechanical parts. It's explicitly designed to be visually stunning, scientifically accurate, and most importantly, easy for beginners to understand. The creator's plan really aims to take raw, complex engineering and distill it down into a tight, optimized 60 to 90-second educational flow. It's all about bridging that gap between intimidating industrial mechanics and engaging, accessible visual storytelling. But, to tell that mechanical story properly, we need to introduce our essential cast of characters. We've got the locomotive, the traction motor, the wheels, the axle, the generator, the braking system, and of course, the passenger coaches. And just to put things into perspective, a single traction motor can weigh over 6,000 pounds all on its own. That's literally the weight of a large SUV. Knowing exactly who is absolutely critical before we can even begin to understand how they all interact out there on the tracks. I mean, these are the heavy hitters that make this whole massive system move. So, how do we actually see them all functioning together? Well, the blueprint uses a transparent cutaway view, and this is just a brilliant visual technique. It literally strips away the tough, opaque exterior of the train to reveal all those hidden internal components we just listed. We start with the familiar, everyday sight of a powerful locomotive pulling coaches, but then, using this transparent cutaway, our perspective shifts entirely to the complex, hidden operations happening on the inside. Section 2. Generating the energy. Starting the process. Okay, here is the exact linear sequence for the genesis of the train's power straight from the animation source. Step 1. A diesel engine or an electric power source generates that massive initial burst of energy. Step 2, that energy doesn't just sit there, right? It immediately flows directly into the generator. And step 3, an inverter steps in to process that power. Now, this is absolutely crucial because the inverter converts the raw DC current into alternating current, or AC. This is what allows for incredibly precise control over the motors in the next stage of the journey. It's a highly controlled, step-by-step cascade of raw energy. But think about it, how do you actually show energy? It's invisible. To make this invisible force visible, the source calls for a very specific visual cue, and that is glowing arrows. Against a clean, dark background, aided by some really dynamic lighting, these arrows map the flow. I want you to mentally picture these glowing arrows as our guiding metaphor for the rest of this explainer. They show us exactly how electricity becomes mechanical power and ultimately forward motion. It's just a fantastic educational trick to visually anchor a completely abstract